Hello, everyone, and welcome to the webinar. Today's webinar is on SolidCAM's feature recognition and machining. And before I continue, actually, just to remind everybody that this webinar is being recorded, and it will be available together with the parts that I'll be using later on the website for everyone to download and review as well. Okay, so let's get started with the webinar. Okay. Okay, I believe now you can also see my screen. And now you can't see me anymore. Okay, so SolidCAM's feature recognition and machining. What exactly is it? SolidCAM's feature recognition is not just automation where you press the part and everything is done. SolidCAM feature recognition machining is designed specifically for the machinist because the machinist knows what kind of technology he would like to use. So this is a tool that will allow him to be the most creative in the fastest way using the technology that he decides to use, using our feature recognition. And as we go through the webinar, we'll see exactly what we're talking about over here. Okay, so the first part of the feature recognition I'd like to mention is we'd like to talk about is our pocket recognition. Now, pocket recognition, instead of machining each individual pocket in separate operation, the pocket recognition automatically parses the CAD model looking for all the pocket features that are identified as pockets. Let's see exactly how this works. We'll start by going into our option of pocket recognition. Okay, and we'll go to choose our home position that I'd like to work. And what I'd like to do on this part is on this top area over here, I'd like to recognize every single pocket, whether it be this surface over here, even these small steps down here, this pocket, all of the pockets that we have here. These holes over here, I don't necessarily want to recognize those. So this is what I want to work on in my recognition. So when I go to define my geometry, as far as this area that I didn't want to do, I'm going to have what they call a filter for the minimum diameter, and I'll just click on that hole over there, showing that that's the minimum. Anything under that will not be taken. So now all I need to do is just click on the part, and it's actually, like I said, parsing the model, and it's now recognizing every single pocket feature that we have on this part. And you can see this as well on the entire part. Every single face has been recognized. The faces inside this hole has not been recognized as I limited it to not go into that area itself. The rest is just defining your technology, your tools, your technology, everything exactly the way the machinist would like to do it. So he'll choose the tool that he wants to work with. The levels do not have to be dealt with because it's recognized automatically from the feature of each tool, from each pocket. Technology, I can define the technology any way I want. Let's say I have to, I like working, for example, with open pockets using profile strategy. And that's it. I'm just going to do save and calculate. And we do save and calculate. You'll see that it picked up every single pocket that we have over there. Running my simulation, and I'll do this with Solid Verify, you'll see that every single pocket has been machined. Let me do it a little slower so you can see actually what's going on. Every single pocket, every single step has been recognized, and it's also going from the outside where it can, and then going further down into the part until it reaches every single pocket, as we can see over here. Okay, and you can see even these small steps, it recognizes those as well. Okay, let me go out of the operation, and I'm going to delete what I just did over here. Why am I doing that? Simple. I showed you pocket recognition, but I'm going to even show you now how we can use our feature recognition, such as pocket recognitions, even in a stronger fashion. If I have my pocket recognition as a template, all I have to do with my pocket recognition, which I have over here, is just take it and drag it to the part. And that is it. Everything will be done automatically and quickly. So that's taking your recognition to the next step. Having the template, which is designed by the machinist himself. He knows what kind of technology he's getting when he uses this. Okay? Now, I'm going to go back to packet recognition in a moment, but now I'd like to touch on a different subject. And I'm going to continue with this part, something called chamfer recognition. Now, the chamfer recognition is an automatic recognition and machining that applies chamfer to the edges of the model. Every single edge feature on the model is recognized and will create a chamfer on them, provides a very powerful capability to automatically chamfer the edges of a model without having to manually pick all the change and apply chamfer to them, like using in a profile operation. Let's see exactly how this works. So again, I'll go into chamfer recognition, and in my geometry, making sure I have the proper home position, I'm going to tell it also, even though I don't have any, then I'm going to tell it to ignore any floor wall angles less than 90 degrees. Okay, we don't have that in this particular case. And my minimum diameter, again, I'm going to keep it at that value. Click on the part, and what's happening now is every single edge feature on this part has been picked up, has been recognized, and we can see that on the part itself. What I also like doing when I'm using excuse me, chamfer recognition is I also like to use my 3D model protection, just to make sure it doesn't gouge, the tool does not gouge any of the edges that are not close to the chamfered edges. Okay, all I need to do now is choose my tool. In this particular case, I'll be choosing my chamfer mill that I have over here. My levels, my chamfer depth, I'm just going to have it at 0.1 millimeter. Just want to break the edge. And in my technology, my cutting diameter of the tool that I'd like to use is going to be 2 millimeters. That's the way I want to work. I'll just go save and calculate. And if we take a look at our simulation, again, I'll use Solid Verify. And I'll run this a little slower than we did before. You can see that every single edge is being machined. But also note that when it gets close to a corner such as this, it'll also stop just before, guaranteeing that this edge over here is not gouged by the tool itself. Okay. Again, let me stop this part. I'm going to again erase this part. And just like I did with pocket recognition before, I'll delete this part. If I have this as a template, and this is probably one of the most useful of the recognitions with the template, because in this particular case, many people only use one tool. All I need to do is take that, drag it to the part, and there we have it. All of my chamfer edges were recognized just by dropping the template onto the surface, and the operation is created. Now, one more thing I'd like to do before I continue. I'm going to actually delete both of these operations, both the pocket recognition and the chamfer. Okay. Now, we can even take this to a further step by creating a process template. If I have a process template that has both the pocket recognition and chamfer, as you see in this particular case, I prepared one that has two pocket recognitions operations, one for doing the finish as well, and the chamfering operation. Taking that, dragging it to the part, will not only create the operations for the pocket recognitions, both for the rough and finish, but it'll also create the operation for the chamfer recognition. So quickly, we can create all of these operations by using the feature recognitions of the pocket and chamfer recognitions, plus the drag and drop templates. Taking a look at the simulation on this entire part that we've done right now, you can see, again, every single pocket is being worked on. We go a little faster now since we saw this before. We can see also here the finish cut on the walls over here, as well as the chamfer that was put up until that edge. Okay, now let's go to our next part. And the next part we're going to show is drill recognition. Now, drill recognition was an automatic recognition of holes for drilling from a solid model with the option to modify the results of what you find. Now, a single drill recognition operation creates a group of holes with a common diameter at varying levels and depth, and a spot drill, for example, operation can work on all the holes and all the different sizes in one operation, accommodating for the diameter for each individual hole. Let's take a look at exactly what I'm talking about over here. Let me go into my drill recognition. And the first thing I like to do is, if we take a look at the part itself, you see we have all different types of holes over here. Okay? Now, I'd like to put a spot drill on every single one of those holes. However, this hole over here, I don't want to do that. Okay? So my maximum size hole is going to be this one over here. So when I create my geometry, we have here a filter for hole diameter. Now, I'm going to start it from 0. In other words, from the very smallest hole possible. But I'm going to give it my maximum up until this edge over here. And you can see that value has been put in over there. So anything between 0 and 20 will automatically be recognized. Now, all I have to tell it to do is just find the holes. Click on Find the Holes, and you can see that every single hole was chosen, except for this large one over here, because that's outside of the range that I had over here. And you can see in each hole, they're broken into different groups. And you can see each shape, the groups. And if I right-click over here, you can also see the shape of each group that we have, of each hole. Okay, we have this group over here, this group over here with the different sizes, and we have this shape over here as well. You can see the shape as it comes out over here. So everything is recognized. We'll just accept that. I'm going to choose my, excuse me, my spot drill. And now we go to levels. What the drill recognition did, it recognized the depth of each hole. But in this particular case, I'd like to make some modification because I don't want it to go down to the very bottom of each hole. I just want to do a spot drill for each hole up until the diameter of this hole. So when I go into depth edit, we have two simple tools I can use. One, we have here auto chamfer spot drills. And I'm going to apply that to all. In other words, it's going to have the spot drill go down according to the diameter of each hole. What's the depth I want it to go down at each hole? 0. In other words, when that diameter of the chamfer mill hits, the spot drill hits the diameter of that tool, that's exactly the depth it's going to go to. I'm going to apply that to all, as well as this, just to make sure I apply that to all as well. Accept that, and save and calculate. And as you can see, and we'll use my solid verify to show this in the simulation. And I'm also going to do my solid verify with a little bit so we can actually see through the part a little. As you can see, it's going down on each part. You can see the sizes are different for each hole. You can see also the depth is different for each hole as we see through the part itself. So each hole has a spot drill according to the diameter of that hole. And you can see it also very clearly when I show it to you like this. Okay, now my next operation is I'd like to use only one drill. Remember, the drill recognition is a single tool operation. So now I just want to demonstrate on one other hole diameter, and I'm going to be using this particular diameter over here, which I know, by the way, is on 2 different levels. Okay, so when I go to my drill recognition, again, when I can create my geometry, when I go to hole diameter, I'm going to go from, in other words, what's the diameter I want to work from? From this one over here. Clicking on that hole, you'll note it puts in the value of 6.8 in both fields. So it's only going to be looking for 6.8 diameter holes. Click on Find Holes, and you can see both of those groups were picked, and they're both on different levels. The tool, I'll be choosing my 6.8 drill, and that's it. In my levels, I don't have to go into depth edit because we already know the depth. It's going to go to the depth that it recognized from each hole. If I want, I can change my technology. If I wanted to have G81, or if I want to have it as a G83, whichever technology I want to use, that's completely up to the machinist. The machinist knows what he wants, and he'll put in exactly the values that he feels is correct, or whichever way he wants to work. All I'm going to do now is save and calculate, run my simulation, again using Solid Verify, and we'll actually see through the part itself. We'll take a different view so we can see it a lot better. And when we run that simulation, you can see the depth of each hole. You can see it going down over here up until this depth over here. You can see these holes up until its proper depth, starting from the top. This one starting from this area over here, the one in back of it, and this one over here as well. Taking a look from the top view, you can see that all of them, both of these sets of holes were drilled exactly the way they were done. This is really helpful for the machinist because it makes it easier for him to pick any of the holes that he wants, and he can define it any way he wants. This is why I always like calling this that this is the machinist's choice. SolidCAM is always the machinist's choice because it gives him control of what he wants to do. Okay, so let's continue now with my next part. Now, this option has been around for a while, but I like to show it every now and then just to give people a reminder. Now, this is what we call automatic hole recognition and machining. Now, automatic hole recognition and machining is a module that's designed to automatically recognize the holes classified into different shapes and groups, then converts the holes into machinable segments, again distributes the machinable segments into all different types of feature sets, and then chooses the proper technology and then creates the operations for them. It sounds complicated, but this is actually what it does. It does this all pretty much automatically. And in this particular case, I have all of these holes in a different location, different sizes, different angles. All I'm going to do now is going to go into Operation, Hole Recognition Technology, and choose my database that I want to work with. What's going to happen now, it's actually scanning the part and locating and recognizing every single hole. Now, this is a large part, I'll admit, so this takes a little longer than regular parts, but as you can see, every single hole has been recognized. You can see every single shape broken into different groups. We have this shape over here as well. You can see the shape over here with the different groups of different sizes as well. So it breaks it down into shapes, groups, this shape down here. In other words, everything is broken down as it says. The next step, as I mentioned, it shows the machinable features, breaks it all down into the different machinable features, and then puts all those machinable features into this actual sets. Once it does that, it actually defines, okay, now that we know the sets, it's finding the proper technology to use from the database for each one of those sets. And you can see as we click on them, you can see that every single group has exactly what kind of technology it's going to be using over there. Next, I just tell, okay, let's start generating the operations. Now, this one, because there are a lot of operations being created, this will take about just about a minute. So you can even take a look at your watch as this is going. This will be taking about a minute of our time over here. But what's actually happening now is that it is going through all of the different feature sets and it's creating the operations for those feature sets. At the end of this thing, you'll see that every single hole will have the operations created for this. And we'll be seeing this shortly as this comes along, just in about another half a minute or so. This should you'll see this starting to create the operations. Okay, just a moment. Gives me a chance to clear my throat. You can see it's working actually now. No, it's not stuck. Don't worry. It's working. And now it's also generating the Toolpath Preview. And in a moment, we'll see all of the operations. Not only will you see only the operations, but you'll also see a preview of the part itself, how it's going to look after it's drilled out. In a moment, we'll see this. We're almost done. And you can see also that the different home positions were created for this. And here is the preview of the part. We'll exit. And you can see that all of the operations were created. And if I go into my coordinate system manager, you'll see that we have positions that were created for each one of those different positions that we have on the part. Let's just do a quick simulation on this part using Solid Verify. And let's run it till the end. You can see every single hole is being machined, and this was done automatically with the automatic hole recognition and machining. And you can see at the end of the day, this created 129 different operations for this in just a few moments. Okay, next. Okay, let's just finish going back to the top. Let's talk about the Hole Wizard. Now, in SolidWorks, we have a Hole Wizard. Okay, now the Hole Wizard machining, what recognizes, SolidWorks uses actually their Hole Wizard features automatically to create different types of holes, such as counterbore holes, countersink holes, your simple holes, and your straight tapped holes, for example, in this part. What we do in SolidCAM is we recognize these SolidWorks Hole Wizards and can create the operations automatically for those holes using the information that we get from SolidWorks. Let's take a look how this works. As you can see on top, we have here Hole Wizard process. Now, with the Hole Wizard process, you can see we have the tapped holes, counterbore holes, countersink, and the simple holes. Okay, so let's take a look at the part itself. Now make it a little closer. And what I'd like to do, I'm going to pin this so it stays open, is I like to work on these counterbore holes. So I'll click on counterbore. And all I have to do now is click on the counterbore hole. It'll automatically recognize the hole, including the pattern that was created with, if this was created with a pattern. And we can see that all the holes were recognized. Excuse me. On the part, you can see that as well. The moment I accept this, we will have the operations created for every single one of those holes with the proper tools. If I want to do another set of counterbore holes, such as this one over here, I'll just continue with that counterbore. Click on that hole over there. Again, it's recognizing everything that's over there. Excuse me. Including whatever was created in the pattern. You can see all of these were created in a pattern. And then accept that. Again, it'll create the operations, as we see over here. Now, tapped holes, same thing. Choose the tapped holes. Let's just go down and choose this particular tapped hole over here. And again, it chooses those holes, recognizes them from the Hole Wizard, knows exactly what type of hole it is, accept it, and it will give me the operations for that tapped hole. Now, these are actual processes that were created, and they can easily be edited. Any single operation here is just a regular operation. Okay, now we've also now have that the Hole Wizard process can be used a lot easier. Let me just delete everything that I've done over here and any extra geometries that I may have. And instead of using the Hole Wizard process over here, we also have them inside our drag and drop. I'm just going to bring it up to the top. And as you can see here, we have a Hole Wizard process for drag and drop. So for example, if I were to click on tapped holes, I will take the excuse me, take the process for the tapped holes and just drag it to that hole over there. And you can see it'll automatically create the operations for that set of holes as is being done over there. Okay? If I do it, let's say, for another set of tapped holes, let's go this one over here. It'll do the same thing for those tapped holes. And you'll see that being created in a moment over there as well. If I want to do counterbore, just take the counterbore process and drag it to the counterbore. And again, it'll do it there as well if I did it to the other one over here. It's being created, all the operations calculated. Okay, and as I said before, let's do the countersink. Let's do countersink to this one over here. And you can see the countersink is being created as well with two different operations. If I were to run the simulation on this entire part, we'll go back to operations and run the simulation from here, solid verify. You can see that every single hole has been machined exactly the way it's supposed to. Counterbore holes, countersink, the tapped holes, everything exactly with the proper size tools that is needed. Okay. Okay. Now, let me go to my next operation, next part, and this is what I like to call the ultimate in in feature recognition. iMachining 3D. iMachining 3D, and in particular on parts such as this one, is the ultimate tool for feature recognition on these parts. It'll take the entire part, every single pocket over here, recognize it, and put an iMachining toolpath on each one of them. And it'll do it also very, very quickly. Let's see exactly how this works. If I go into my iMachining 3D operation, you can see there's no geometry that has to be picked. It's taking the entire target. And since iMachining 3D works with multiple tools, I can define multiple tools over here. So for example, I'm going to choose my first tool. Okay, 6mm end mill. I'm going to choose my second tool, a 3mm end mill. And I'm even going to choose a third tool, a 2mm end mill. Oops, sorry, made a mistake over there. I selected my, I pressed on select 2, for example, by mistake. No problem. Go to the third tool. There we go. And choose my 2mm end mill. All I have to do right now is if I want to make any changes in my technology, I can, but I'm just going to leave everything exactly the way it is. Save and calculate. So what we did right now, all we did was choose the iMachining 3D, which recognizes the feature on the entire part. And the tool passes, as you see, as we're speaking, is automatically being created for 3 different operations. You can see the 3 different operations here on the side, and they're all being calculated now. The first one finished being calculated. The second one is in the middle of being calculated. As this is recognizing now, we're also with the, wherever the first tool with the larger 6mm end mill was not able to create an operation. And when this finishes, then it'll also update the stock to recognize what stock is left over to be finished compared to the stock to the target. So it sees exactly what features are left to be machined. Now, since this part has a lot of small little pockets, so it does take a little longer. But it's worthwhile looking at a part because this is actually a pretty intense part when it comes to machining this manually. Okay, we're almost done. Now the second operation, the toolpath is being generated. And stock is now going to be updated as well. And then the third operation will be calculated. We'll just let it work, give my throat a rest. Okay, it's finished the stock updating, and now it's building the operation toolpaths for the last operation. Okay, as you can see, all of the toolpaths has been created. Running my simulation, and I'll use Solid Verify. You can see that every single pocket has been recognized. You can see the first tool operating, doing whatever it can. Now the second tool is operating, going into the areas where the first tool was not able to machine. Okay, working in these areas over here as well. We're going to let that finish. Excuse me. And when this one finishes, you'll see that the third tool will even go to the areas where this tool was not able to go, because this area does have a lot of small areas as well. So in one operation, we were able to do all of them, and we'll see this in a moment. And what's really nice about this, again, this is a feature recognition, and it allows the machinist to apply the technology that he wants to use. This is, again, why SolidCAM is the choice for the machinist. It's the machinist's choice. The features, we make it easier for him. The technology, he does the way he wants it. Perfect combination. Finishing off exactly each pocket over here. We'll see that in a minute. But you know what, second? I have an idea. I'm going to stop this for a moment. Okay? I'm going to delete what I've done over here. Okay? So let's delete this. Why not use a process template instead of doing everything I did before? If I have a set of process templates, which, by the way, is always available and it's created by the operator himself, by the machinist, I'll just take it. So I'm just going to take the one that I have over here. You see, I'm machining 3 different operations with the tools, a 6 millimeter, 3 millimeter, 2 millimeter. I'm just going to take it, drag it to the part. And without having to define anything inside the operations, you can see that it is creating the tool passes just by dropping it onto the surface. So the combination, again, the combination of the recognition of the part together with the drag and drop template options makes this an unbeatable tool for the machinists. And it's not a tool just for demonstrating, but the actual machinist is who's the one that actually uses these tools. As you can see now, it's almost finished, and it works actually pretty quickly. Running my simulation quickly on this. You can see again the pockets as we showed before. I believe this one will run a little quicker. What you'll also see is that the third tool, which will be coming in a moment, we'll be working on all those small little areas that the previous tool cannot go into at all, giving us that, basically picking up everything, including these small little steps over here that we didn't pick up before. One of my favorite tools is combining everything with the drag and drop where I can to make the automation and the recognition even better. Now, one last part I'd like to mention to you. To open up this part over here. And I'm going to go now into iMachining 2D, because iMachining 2D today uses feature recognition technology. For example, I'd like to recognize the outside stock of this part, okay? Okay, if I were to right click, you can see that it's actually a block around the part itself. And I'd like to create an operation for it. Okay, the operation will just recognize the outside stock and the shape, the outside features of this part itself. If I go into iMachining 2D, we'll choose the option of outside feature recognition. All I need to do, note, no geometry needs to be chosen. I'm just going to select a tool. And you'll note that the moment I do this, it shows you exactly what is going to be machined. It shows you the outside feature of the stock is going to be machined up until the outside features of the part itself. The depth is automatically recognized. Save and calculate. And you can see your toolpath is automatically created. Running my simulation on this using Solid Verify, you can see this working beautifully on the outside of the part, exactly from where the stock is. Now imagine this part, how we used to have to create an operation for this is if you had to choose a geometry for the outside of this, it was always very difficult. But now we recognize the outside features of the part and we recognize that automatically and simply, making it easier to program with. Now I'm going to do one more operation as far as these pockets goes. Okay, because what I'm going to do with the feature recognition of these pockets is going to see the actual pocket itself according to the depth, and it's also going to see up until the stock itself, up until where it has to machine on the outside. So if I were to create another iMachining operation, in this particular case, I'm just going to choose my faces, do one, choose those faces over here. And you notice each one of those faces is at a different level. Okay, it doesn't make a difference. It'll recognize each face at its level. And when I choose a tool, I'm just going to use the exact same tool that I had last time. What you're going to see is as follows. It shows you exactly what's going to machine and according to the levels. All I'm going to do now, save and calculate. Simulate, and you can see that it's going to machine exactly where it needs to machine. Every single pocket to its depth and where it's starting from, just from the outside of the part. Now, there's one more thing I'd like to show you, and then we'll be finished. What if I were to take this first operation that machined the outside of the part, and I'm going to delete it, or suppress it, for example, which is basically the same thing. If I were to go back into the operation where I machine the face features, you'll see that it has changed now, because we automatically recognize what the outside stock, the feature of the outside stock, and we work accordingly. All I have to do is just save and calculate, and you'll see now we'll have a completely different toolpath, one that includes the outside of the stock as shown over here, machining everything exactly the way we wanted it. So what have we seen here? We've seen here feature recognitions for our regular pocket recognitions, for chamfer recognitions, drill, automatic hole recognitions, the SolidWorks hole wizard recognition, and as well as iMachining both 2D and 3D. So we now recognize a lot more than we've done before. All of these recognition features are very easily being used, and if you combine them with your drag and drop, it makes it even that much easier. Okay, and as I said, because it's so easy, and because the machinist is the one that decides what kind of technology it uses, this is the tool. SolidCAM is the program for the machinist. Okay, I see there are no questions at this moment. As I said before, this webinar has been recorded and will be available to everyone later on. I just want to remind everybody that in another week and a half, we have SolidCAM World coming up. And I hope to see all of you over there. And trust me, we have a full venue and some surprises there as well. So see you at our next webinar. And of course, I will see you at SolidCAM World in Orlando. Take care, everyone. Have a great weekend and see you next time.